Hey there! Today we're going to learn how to analyze P&IDs. First, we need to know that P&ID stands for Piping and Instrumentation Diagrams. A common misconception is to think that P&ID and PID are the same. This is not true since PID stands for Proportional, Integrative, and Derivative Control, and it is just another topic within process automation. P&IDs are the schematic representation of the piping, the equipment, the instrumentation, and the control machinery for a specific industrial process. Getting to know the symbology that is commonly used in the P&IDs is the first step into understanding and analyzing them. Here is an example of a P&ID of a chemical process. Let's start by analyzing the following instrument. The first letter describes the parameter that is being either controlled or monitored. In this case, the parameter would be pressure. The second letter is used to describe the type of device that is used to control or monitor that parameter. In this case, the letter C stands for controller. Thus, we have a pressure controller. The number below describes the logical numerator. There can be more than one pressure controllers in a process, so giving each one a number helps to tell them apart. A feedback loop is represented when different instruments have the same logical numerator. For instance, the temperature controller, the temperature transmitter, and the temperature recording belong to the loop 101. There are several instrumentation symbols that can be found in the internet, and all of them are regulated by international organizations so that they are globally understood. If it were the case in which the instrument had 3 letters instead of 2, the procedure would be the same. In this case, the letter F stands for flow, the letter C stands for control, and the letter V stands for valve. The P&ID can also provide information on where the instrument is located. For example, if the instrument is represented by a circle, it is located in the field. If the instrument is represented by a circle with a solid line, it is located at the front of the panel. This means that it is accessible to the operator. If the instrument is represented by a circle with a dotted line, it is located at the back of the panel. This means that it is not accessible to the operator. And if the instrument is represented by a circle with 2 solid lines, it is located at an auxiliary location. The piping can be represented by different lines. For example, in this P&ID, there are 2 types of lines, a solid line and a dotted line. A solid gray line represents the main piping, while a solid black line represents the instrument piping. Also, the electrical signal can be represented, and it is represented by a dotted line. And both pneumatic and hydraulic signals can also be represented in P&IDs. Equipment like pumps, heat exchangers, and valves are represented in P&IDs, just to mention some. P&IDs are widely used within any type of industry. When P&IDs are used, processes can be planned and visualized. For example, if the process were to fail, the determination of the instrument, pipe, equipment, or machinery that has caused the damage, or that is damage itself, is quite straightforward because P&IDs were easy to follow. P&IDs use a standardized symbology so that any process that is graphically represented by these type of diagrams can be read all around the globe. Therefore, it is important to be familiarized with its symbology. In addition, controlling an industrial process is important due to safety, quality, profit, and optimization reasons, among others. Thus, by being able to read and analyze a P&ID, the control of a process will be more efficient. So, now we're ready to analyze a P&ID.